Hi, I'm DJ Ware. On this episode of the CyberGizmo, I want to give you some of my predictions for 2020 in terms of hardware, and we'll take a look at those right after this. So I wanted to look at, I'm sure there'll be other YouTubers that cover some of their predictions for 2020. I'm going to base mine on what I know, and I'll probably do some guessing as well during this. And so let's get started with that. So I'm going to be looking at two groups, the CPUs from AMD, ARM, Intel, NVIDIA, and RISC-V. RISC-V I'm not going to cover today simply because this is the first day. This is December the 10th, 2019. This is the first day for their annual summit out in San Jose. So I want to wait at least a couple of days, see what they actually announced there. There are quite, there's a lot going on in the RISC-V. There's a lot of development and there's a lot of releases planned for 2020. So I'll talk about those in a future video. I also want to cover the GPUs. There are some significant things that are coming, both from AMD and Intel, and NVIDIA has announced that they're planning a release pretty early in 2020 as well. I don't think that's a big surprise. I think a lot of people know about that one anyway. So I want to start with the AMD CPUs, and the largest of the chips that's coming is the AMD Threadripper 3990X. That is to be released, of course, in 2020, and it is, like the others, based on the EPYC Rome architecture, which is the EPYC version 2 of their processors. It is a 7-nanometer chipset, and it does have 12-nanometer I/O dies. The clock rates at this point, I haven't been able to find any information on it, and AMD is being pretty tight-lipped at this point, and I suspect that will remain true until they officially announce the release date for the CPU. We do know that it is going to be 64 cores, of course, and 128 threads. It has 288 megabytes of cache total and 280-watt TDP. Now, TDP doesn't mean what it used to. It is not the maximum amount of wattage. It is, I think it's kind of an average, so you can expect that you'll probably have times where you'll need more power to be able to power that chip. It is 128 PCI 4.0 lanes. It does use the same socket TRX40 as the other Generation 3 Threadrippers, and as far as the cost, at this point, it's unknown. I'm not even going to speculate. Don't know. Other CPUs that are coming are AMD Zen 3, and that's coming in 2020. Those are up to 64 cores, 128 threads across an 8x8 core, and that's going to be between 120 and 225 watts TDP. They are, of course, PCI Gen 4.0 as well. Don't know how many lanes there'll be in that one, but I do know that it will be using 8-channel DDR4 memory. It is the 7-nanometer plus die from TSMC, which they have already started volume shipping in this current year. 20% increase in transistor density, about 10% lower power requirements. Possible support for AVX 512, and it uses the same AM4 socket as the other Ryzen desktop processors used today, so no change in the motherboard, although I suspect there'll be new motherboards to support this. The ARM CPUs, the Hercules chip is coming in 2020. That will be, I think I'm not quite sure. They say 7-nanometer plus and 5-nanometer, so there'll probably be 2 releases during 2020. I know that TSMC is not expecting to do volume production on 5-nanometer until March, I think. Well, that's not quite true. They'll have volume production for limited production in March, but I'm not quite sure yet as to when the date is when they'll have full production ramp up. But it will be in 2020. We know that. So the cores, we don't quite yet know how many cores will be on the chips. I'm assuming that it'll start like it always does with ARM. There's 4 cores, and then there'll be the big little implementations and then some higher form of the core. Now, these are SoC based. These aren't the server chips. So these are designed to be built into a SoC, a system on a chip. Clock rates, don't know, but we think it'll be around 3.3 gigahertz. But this is unconfirmed. Don't know that. But I do know it's going to have to be faster than the current Cortex A76, which runs around 3.1 gigahertz. So it has to be faster than that. Dynamic IQ technology is included with this one, and that's balancing the performance of the CPU with the amount of power draw that the chip is requiring. So that's good. It should produce about a 15% gain over the current Cortex A76 and about 10% less power draw than the Cortex A76. 5G is built in on the chip, of course. I think everything is these days on any of the new ARM chips. It is a mobile design platform, after all. It is designed to compete with x86, Intel x86 on the mobile platforms. And so don't know what the performance of this will be. And of course, it's hard to speculate without actually testing. And I usually don't. So don't know how much faster it'll be. And I haven't heard any claims from ARM how much faster it will be. And of course, that will depend on the manufacturers of the chips like Qualcomm or some of those guys. So don't know. As far as Intel is concerned, yeah, we're still waiting on Ice Lake, aren't we? Didn't quite make it in 2019. They postponed it to 2020 for the desktop. It is, of course, the infamous 10 nanometer die that we've been waiting for. The only thing I know about is the Core i3, which is 4 cores and 8 threads, and I'm sure there'll be a scale that goes up for the Core i5, Core i7. And then the X series chips as well. So, but we do know that it's about a 3.6 gigahertz base clock. Mobile is that really base? Probably not. It's probably boost. I'm thinking it's probably a boost clock, not base. Mobile platform would generally not be that high a clock rate. TDP mobile 8 to 15 watts. Desktop, don't know. It does have the AVX 512 instruction set, and it also has a new security encryption accelerator that's inside of it, which is the SHA-NI or Vector AES instruction set, which they claim is 75% faster than the current AES-NI instruction set. Decryption, don't know. Intel's not saying what that will be. But we do know that the Xeon processors are slated to launch in 2020 that are based on Ice Lake as well. The support for 5 and 8K monitors are built into the discrete GPU on board. Don't know if it'll be the Intel Xe, doubt it, but we'll see. Also, Intel, as far as my comment here, is that they appear to be stalled. And there have been rumors floating around that the 10 nanometer desktop might just be scrapped and in favor of a 7 nanometer design. Those rumors flew around about 2 months ago. They're back, and there's even speculation that Intel is working with Samsung in order to produce a 7 nanometer chip. But again, that's just rumor. Intel Tiger Lake is slated for release in 2020. That is a 10 plus nanometer design. The only thing I know about it, again, is that the base one will be 4 core and 8 threads. No big surprise there. As far as the clock rates, don't know. There's supposed to be 2 models that are released, a 9 watt and a 25 watt TDP. So, that likely this chip is really meant for the Ghost NUC. Since it is sort of a mobile-like device, so that's the speculation. It will be LPDDR5 memory with 6.4 gigatransfers per second. PCI Express Gen 4 again, and this time we know that the Intel Xe will be embedded in that chip. As AVX 512 is supported, and like I said, probably headed for the NUC, the Ghost NUC. Some general comments that I have on the CPUs. AMD continues to increase its presence. I don't think that's a real big shock. We all know that that's happening. not only in the desktop, but the high-end desktop, the mobile, the enthusiast PC, and also in the server marketplace. They are definitely increasing their presence in all of those things. ARM may seriously challenge Intel's mobile platform. I think the question here is whether, for Linux, is whether or not more of the Linux developers will start building packages for ARM or not, at least for the desktop. Now, there are a lot of packages for ARM server. I mean, I personally have only run into 2 instances in the last 3 years where packages I had to build from source. But yeah, it's on the server side, the ARM is fine. It's pretty secured. But on the desktop, I know some of the people that have bought the Pinebook Pro have been talking about the lack of support for some of the desktop apps. So if the Linux, of course, you know, that's a buyer-seller thing. If there's enough market and enough demand, then the Linux developers will take the time to do the package development. My opinion, and the other part of ARM is that Intel has confirmed that Apple will be moving, to, at least on their mobile platforms, to ARM in 2020. So Intel has said that publicly, that Apple is definitely moving. Intel appears to be stalled, and I don't think that's a big surprise either, and their direction seems very unclear to me as to what they're trying to do or want to do. I think they're just kind of lost at the moment as to what to really do to answer AMD's onslaught. Again, RISC-V, cover that in a future video. So let's take a look at some of the predictions I have and some of the things I know about the graphics processors. And we'll start with AMD. We know the Radeon RX 5800, which is the Navi 12, is slated for release in 2020. There's already been a number of RX 5000 series machines released that compete on the lower end. The 5800 is based on the same Navi 10 RDNA architecture as the previous 5700. It is a 7-nanometer die. That's the same. Some of the specs are total guesses. 4096 shaders, GDR6, 256 bit memory size. And it's targeted really to compete with the 2070S, the 2080, and the 2080S. And so we'll talk about the next thing that's coming in 2020, which is the AMD Arcturus. Don't know exactly what part of 2020 this will be released in. I doubt they'll step on the 5800, although they did. AMD did step on one of the Vega processors last year. It is based on RDNA 2. They could have an announcement at CES. They may wait. I don't know. I have no information about that. I have no insider information with AMD. It is a 7-nanometer plus. This is stuff that AMD has talked about publicly. It adds support for bfloat 16 and adds support for ray tracing. We know that. So AMD is definitely entering the ray tracing game. Whether or not there'll be dedicated processors to it, we just don't know. At this point, I mean, I don't. Maybe you do. NVIDIA RTX 2080, it should say, Ti Super. That's to be released in 2020. It's based on the TU120 GPU. It's 4609 shaders, and that enables full silicon on the 2080 chip. 576 tensor cores and 72 ray tracing cores. It uses faster 6 gigabit per second GDDR6 memory. And it has a 352-bit memory bus, and of course, 11 gigabytes of VRAM. I don't think that's a real big surprise, but it's going to be interesting to see what they do with the Ti now. That looks to me like it's going to be stomping all over the existing Ti, excuse me, the existing Titan, and so we'll see what they're planning to do with that. Intel Xe GPU is coming out this year. And this is the long-awaited Intel offering for the graphics processor. This is sometime mid-2020 is when it's slated for release at this point. There could be an announcement at CES. It is a 7-nanometer design. It's supposed to be, and this is Intel's words, 2 times more performant than the Gen 11. It does have support for ray tracing. T-flop scaling is up to 0.1 p-flops, so it's pretty significant processor. Cray has already chosen it for their Aurora supercomputer in 2021 as the base graphics processor that'll be going into those. So obviously it must be pretty good if Cray is going to be installing that in their flagship supercomputers. But we'll see. I mean, we don't know. We don't have any benchmarking tests. We don't know. But it has a very broad target, which indicates to me there's probably multiple models of that card. Home PC, gaming PC, enthusiast PC and servers, and also high-performance computing. And that's a pretty wide range of targeted markets for a single card to try to address. So I suspect there'll be multiple models here. So some thoughts on the GPUs. So yeah, NVIDIA is going to continue to be the market leader, at least at present. But, you know, to me, it appears that NVIDIA seems to be about to fall into the same trap as Intel did. And this is surface, it's just a guess. But they appear to only be innovating just enough to stay competitive in the various tiers of the market. That's a dangerous game. If AMD decides to flip around on them and do a leapfrog, they may be caught out very quickly. That's not a very smart ploy. And I know it's based on cost and based on revenue, and so NVIDIA is only going to do what they want. You know, that's the typical thing you run into when there's no competition. So for Linux, however, AMD is really this is my opinion, not a fact. AMD is the preferred platform because there are a lot of proprietary driver issues with NVIDIA. I personally have seen a lot of screen tearing with NVIDIA, particularly with some of the software that I run. AMD is still playing catch up, though. As you noticed in the slides, they don't have something that excels beyond the 2080 Ti. So yeah, I think we're going to have to wait and see what happens with RDNA 2. It looks good on paper, but we'll have to wait and see because don't know the full specs on it yet and don't really know how it's going to perform in the real world. Intel, same thing. They're slated to enter the market in 2020, but again, we don't know how good it's going to be. Now, the fact that Cray chose them, that's interesting, and it's telling. But I'm sure those cards are not going to be. I'm sure that the high-performance computing cards are going to be a lot different than the ones they sell to us. So. Some closing thoughts. It's always difficult to predict the future, especially when you don't know the specs, you don't have any data, and you don't have the cards to test. So that's it's pretty sketchy. I may be wrong, and this video may be proven dead wrong, but hey, it's an attempt to try to see what's coming. One thing is clear to me. This is a pretty exciting time to be involved in Linux because, you know, as I've said before, and it's showing again with the third generation Threadrippers, Windows is having a heck of a time trying to handle these large core machines. And here comes AMD with a 64, 128 thread machine. Linux is going to eat that right up. It's not going to have any problem handling that, but Windows is definitely going to have a problem with it. Linux has been running under Epic for, almost a year now. Well, maybe not quite a year, but it's been quite a while. They've been running on it and without any issues that I know of. So that's pretty clear that Windows is going to be chunking along trying to keep up with all those cores. I was going to make one other comment here. I think if you're in the 30-year-old age group and under, it probably will be within your lifetime that you'll see cores in the millions. I won't see it, but you certainly will. So yeah, that's going to be the issue that all these operating systems are going to have to adapt to, including Linux. I don't think Linux is prepared for that, but they do have a few years to work on that. So the other thing is competition, of course, is good for all of us. It drives innovation. It gets us better products, and hopefully it'll hold the cost down because these guys are going to be competing for market share. And if they have products that are similar, guess what knob they're going to pull, and that's going to be the cost knob. So yeah, and of course, I'll do RISC-V as soon as I can. I hope you, and as always, switch back here as well. And as always, I hope you enjoyed this kind of a cursory look at what's coming. I hope to get my hands on some of this stuff, and I don't think I'll be getting a Threadripper 3990X to test, but I'm sure the cost will be a lot higher than I would care to spend, and I personally probably wouldn't be able to drive that kind of a CPU anyway. My workload isn't quite that high, but I hope you enjoyed this video today. I hope to see you in the next one. Please like and subscribe, and as always, see you again next time, and bye for now.